tonight or today we're solving equations using multiplication and division. When you use multiplication or division to solve an equation, you need to still isolate the variable. So the standard we're looking at is I can solve linear equations in one variable. The multiplication property of the following says that you can multiply each side of the equation by the same key thing, non-zero number, to get equivalent equations. You're going to always notice something like this. C can't equal 0. Remember, if you multiply by 0, you'd end up with 0. So if we are multiplying sum unknown divided by 3 plus 4, now in your head you might be thinking, I know what that is. The opposite of divided by 3 is we're going to multiply by 3. And we might even put 3 over 1. On the other side of the equation, we multiply 4 times 3. The equivalent equation is x equals 12. We're still going to work with equivalent equations in both multiplication and division. What if we have 2 times x equals 24? If the inverse of multiplying by 2, remember, we want to isolate that x. That means 2 times x. The opposite of multiplying by 2, this line means division. So some of you like to write it out this way. You like to put 2x, and I'll even see some very funky stuff here. I'll see 24, and I'll see it's divided by 2, which I agree with. But then out here, I'll see divided by, put it this way. No, I can't do it this way either. Because as our equations get more complicated, this doesn't really show me what you're doing. So use that fraction bar for x to mean division instead of the division symbol. And x in this case would be our equivalent equation 12. Notice again, it says c can't equal 0. Remember, division by 0, anyone remember what that is from the first day of school? Division by 0 is always undefined. So it is always undefined. We're going to try a couple problems, then we'll do it going to your notes. Isolating x. X is being divided by 5. The opposite of dividing is to multiply. On this side, I'm going to think of it as 5 over 1. Since I don't have a fraction on this side, I can just think of it as 5. What happens to 5 over 5? 5 over 5 is the same as 1. 1x divided by 1 leaves me with 1x or x. And now I'm going to take 5 times 14. 5 times 14 is going to give us 70. If we check it, the check says 14 has to be equal to some number divided by 5. We are replacing this x with 70. And now if you check on your calculators, 70 divided by 5 equals 14. What about this equation? We're still isolating our t in this case. Now we make it an x instead of a t. T's look too much like pluses. So negative 2x equals 12. The inverse of multiplying is to divide both sides by negative 2. When I divide by negative 2, I get negative 6 equals negative 2 over negative 2 is the same as 1. So in this equation, when I'm solving, I get x equals negative 6. I always like putting my variable first. X equals negative 6. I want to check it. So I'm going, oh, it's checking. This really helps you when you get into more complicated equations. So 12 equals negative 2. I don't want to say x. X is actually equal to negative 6. Negative times a negative is positive, and it checks. So in your notes, example 1, isolating our variable y is being divided by 3. So since this line means division, the inverse of dividing is to multiply. 3 over 1. Do I have to put 3 over 1 on this side? I could. Well, 5 times 3 is 15. Y equals 15. As we go to check this, the check says y divided by 3 equals 5. But we want y to be 15. And 15 divided by 3 is 5. Our second example in our notes is negative 2.5 times x equals 20. The opposite of multiplying by negative 2.5, divide by negative 2.5. X is equal to, when we do our division, negative 2.5 goes into 20. You take out your calculator, you can do division. Positive divided by negative is negative, and 8. I gotta check that. To do my check, the original equation said negative 2.5x equals 20. I'm looking at negative 2.5 times the negative 8. Well, you know negative times a negative is positive, and in this case it checks. Here's a situation. We have to identify our variable. 90 basketball players show up for a tournament. Write and solve an equation for how many? 5 people, 2 teams. So we are trying to find x is how many. X is going to be the number of 5 people, or 5-person teams that we can have. If I'm looking at this, I have 90 people that showed up and 5 people on the team. 5 times x, remember 5 written right next to the x means multiply, so dividing both sides by 5. 90 divided by 5, x is going to be equal to 90 divided by 5 is 18, which means we can have 18 teams. The question often comes up is, what if instead of having x divided by 3 is equal to 7, I have this problem, 1/3 times x equals 7. What is the inverse of multiplying by 1/3? Well, remember, the reciprocal of 1/3 is actually 3/1. I'm going to multiply both sides by 3/1. Now again, on this side, we could just put 3. As we look at the left side of our equation, 3/3 becomes 1. I'm left with 1x equals 21. Is this the same if in this problem we would have multiplied by 3/1 and by 3? The exact same. So remembering, one thing that's kind of cool to think about is that if you have something like 1/4 x equals 6, that's going to be the same as x divided by 4 equals 6. Here we're multiplying by the reciprocal of 1/4. The reciprocal of 1/4, which is 4/1. Here, when we solve this equation, we are looking at multiplying. The inverse of dividing is multiplying by 4/1. I am going to get the same solution, x equals 24 in both cases. We're going to be starting our 2-step equation soon, so hopefully these 1 steps are making sense to you now.